So this is asking us to match the vocabulary word to a definition, diagram, or appropriate geometry labeling. So the first thing I'm going to do is look through the vocabulary words. So we have point, vertical angles, line, plane, ray, supplementary angles, segment, translation, reflection, rotation, and complementary angles. I'm actually going to start at the bottom. Complementary angles are two angles that add to 90. And if you notice, that matches 2. So I'm going to put the answer on the left-hand side. That's Roman numeral 2. Hopefully, if you know complementary, you also know supplementary. And supplementary angles add to 180, which is the Roman numeral 3. So I'm going to put the answers over here. A couple of the diagrams I'm going to get real quickly. Let's see. We have a ray, which is E, and that goes with X right here. That's a ray, so I'm going to match that up with the X. We also have a segment, and a segment is this fourth one, which is Roman numeral 4. And then I'm going to look through a few more. I'm going to put the answers on the left. See if you can figure out the correct answers, and I will post them real quickly. So here are the final answers. The point matched 5, and it says usually represented by a dot. So usually represented by a dot. Vertical angles was number 6, which is right here. So it's a pair of non-adjacent angles formed by the intersection of two straight lines, and the angles are equal. The line was IX. That's really number 9. A geometric object that is straight, infinitely long, and infinitely thin. The plane is similar. It's a flat surface that is infinitely large with no thickness. We already had a ray, we had supplementary angles, we had a segment. The last ones are different types of transformations. So a translation was number 7 technically. It was moving a figure to a new location with no other changes. A reflection was the very first one. The very first one says that it is reflecting across a line, so it's on opposite sides. So that's XI, that's just I. And a rotation, the last one, goes with the very last one where it says it is turned about a given point. The last thing they wanted us to do was they wanted us to circle the 3 vocabulary words that are considered undefined, and they are the foundation of geometry. So the ones that are undefined, I'm going to circle in black real quickly. The ones that are undefined were point, a line, and a plane. Those 3 are the ones that are considered undefined, and the others all come from those. This question says to name each of the following angles given only their description. An angle with a measure of exactly 180 is called a straight angle. And it looks something like this. It goes all the way from there to there. It's half a circle. An angle with a measure of an exactly 90 is a right angle. And that looks like this. An angle less than 90 is acute, and that looks kind of like this because it's less than 90 degrees. And an angle that is greater than 90 is obtuse, and it looks something like this, where it has to be more than 90 degrees but less than 180. This question asks us, it says, given the figure below, for each of the angles listed, write the number that it represents. So you have to look at all four and figure out which numbers go with it. So angle ADB, I'm going to trace. Here's A, D to B. Hopefully you can see that that is angle 1. Go ahead and fill in the other ones and check yourself, and I will write the answers. So if you see, I wrote the answers. Angle BEC, that's this top one, that's angle 4. Angle DFC, I'll trace it again. DFC is angle 3, that's right here, angle 3. And the last one is DEF, and that one is right here, and that's angle 2. This says, given the diagram below, answer the following. So they would like us to find collinear points on plane R. So plane R is the white one right here, and they want collinear points, so points that are all on the same line. You could do those three, which are K, J, and L. You could also do M, J, and N. M, J, and N. Those are also collinear. Let's see, the next question says 3 points that lie on R and S together. So 3 points that lie on R and S together would be N, J, and M, because they're on both. So N, J, and M. The next part says 2 collinear points on line R. 2 collinear. There are a lot of choices on plane R. That's this one again. So if you just said J and K, that's allowed. If you wanted to say J and L or K and J, that's also allowed. And the last one says name 2 non-coplanar. So that means they're not on the same plane. So if I picked Q, then one that's not on the plane would be, say, L. There are lots of choices for this one. This says point A is at 0, -6 and is translated 7 units to the left and 3 units down to form A prime, and they want the coordinates of the new one. So first I'm going to graph the points. So I plotted the point A, which is at 0, and then you go down to -6, and then it says to go 7 units to the left. So I'm going to go 7 this way, and then it says 3 down from there. So I have to go down 3 more, and they want to know where A prime is. So hopefully you can see that if we're here, this point, and we went 7 to the left, that's going to put it at -7. If we're at -6 and we go down 3 more, that would be on the graph at -9. So the coordinates of the new point would be -7 and a -9, and that would be A prime. This says when triangle ABC, that's this one, is rotated 270 degrees clockwise. That is 3 turns, and clockwise is to the right. About the origin, which is right in the middle, they want to know the new coordinates. So what you need to do is you actually need to turn your paper 3 turns and find out the new coordinates of vertex A. So I'm going to turn my iPad 3 times, and I'm going to put where the new point would be and write the coordinates. See if you can get the right answer. When you turn your paper, it should end up right here at -2, +1. This says we need to reflect triangle ABC across the line y = 1. So the hardest part for some people is graphing the line y = 1. Well, hopefully you'll remember that that means it has to cross the y-axis at the number 1. And the number 1 is right here. This is the y-axis. So it's a horizontal line that looks like this. So this is the line y equals 1. At this point, try to reflect the triangle across, draw in the line of reflection, which we have, label the new image, and then state the new coordinates. I'm going to fill in the answers for you. See if you can do it. Hopefully you got these coordinates. So notice the thing that's important is the distance away has to be the same amount. So if you look, this is 1 away this way, so this one has to be 1 away. And the coordinates of this point would be at 1, 0. If this is 2 units away to the C, then this has to be 2 units away to C prime. And the coordinates for that would be over 6 and down 1. And then the same thing, you would need to count 3 more to get to B, so I counted 3 more. So B prime would be at 6 and negative 4. This question says we need to reflect this triangle, ABC, across the line x equals 1. So that's similar to the last one that we did. The only thing is this time the line x equals 1 is a vertical line. It crosses the x-axis at 1, so it's actually a line that goes like this. So first draw in that line x equals 1, and then we're going to reflect it over that. So go ahead and try to do the reflection and list the new coordinates, and I will do it as well. So this is what it should look like. You should have A is in the same location because it's folding right on the line, and the coordinates of A prime would be 0, 2. And then B prime is right here. And so remember, you always want to start at the origin, which is here, and then count how many over and how many up. So in our case, that would be over 3 to the left and about 5 up. So those are the coordinates. And the last one is the coordinates of C prime, which from the origin is over 4 and up 2. So the coordinates are negative 4, 2. The first part of this question says what transformation will create A prime, B prime, C prime, starting from ABC. And hopefully what you can see is the reflection across the x-axis. The next part, part B, says on the graph rotate the triangle 180 degrees about the origin to form A double prime, B double prime, C double prime. So go ahead and take this first one and rotate it with your paper 180 degrees, which is 2 turns. So go ahead and do that, and I'll put the new image and I'll label it. When you do that, you should get this triangle right here in red. The last part says we need to translate the original triangle ABC so that the new coordinates of A triple prime are at negative 4, 0, and then draw the whole triangle. So first I'm going to take the original point right here, and I'm going to move it to negative 4, 0, and then draw the rest of the triangle. See if you can do that. So in the end, for part C, you should have the black triangle right here because we translated the whole original triangle so that A triple prime was at negative 4, 0. And this is what you should have gotten on your graph. So the first thing I notice is this says we need to plot these 3 points on the graph below. So I'm going to do that in green. Then it says plot after the non-rigid transformation. So I'm going to take all of these points and plug them into that formula, which means I'm going to multiply everything by 2. And then the last one says to plot it after the rigid transformation by plugging the original points into here. See if you can do all 3 of those, and I will do the same. So I plotted the original 3 points below, and you have the triangle that's there. I'm now going to follow this formula, which says do 2x and 2y. So I'm going to write the new coordinates. The first one, if I double both of those, would be 0, 6. See if you can do the rest and then plot it. So if you notice, I doubled all of those coordinates and I got the bigger triangle. Hopefully yours looks better on your graph paper. And that again was a non-rigid transformation, and that's because it got bigger. The last one I'm going to do in red, so I'm going to take the points and I'm going to plug them in to this formula, and I'll write them in red. So if you notice in red, I just plugged in the points they gave us originally at the top, and then I plugged them into this formula, and these were the coordinates that I got. And then when I plotted it, I got this triangle, which looks the same as the green one. And that's because it is a rigid transformation, and rigid transformations are the same shape and same size. So for part C, the difference between a rigid transformation and a non-rigid transformation, non-rigid, like is non-fixed, that means it could be bigger or smaller. A rigid transformation means it's exactly the same size and shape as what you started with. Question number 11 has 3 parts to it, and it says, which rotations about the origin will map a figure onto itself? Choose all that apply. So if I look at this one, this shape here, if you rotate 90 degrees and turn your paper 90 degrees this way, it won't look the same. If you rotate it 180 upside down, it still won't look the same. 270 won't look the same. The only one that looks the same is 360. But if you look at the next one, which is the rectangle, if you rotate it 90, it won't look the same. It'll look like this if you turn your paper. But 180 does look the same. 270 does not, and 360 always does. And the last shape, which is kind of strange looking, if you rotate 90 degrees, it will not look the same. 180 does, and so does 360. So number 12, it says if angle 1 is 6x, so right here I'm going to put a 6x, and angle 2 is 2x plus 36. First of all, they want to know what are these angles called, and those angles are called vertical angles. And vertical angles are equal. So the next thing they ask us is to find the value of x. So I'm going to solve 6x equals 2x plus 36. Go ahead and see if you can solve for x. So when you do that, you should get that x is equal to 9, and I did the work on the right. In the next part, they tell us something. They tell us that angles A and B are supplementary. And hopefully you know that that means that they add to 180 degrees. So the equation I'm going to set up is angle A, which is x plus 2, plus angle B, which is 2x plus 4, is equal to 180. Go ahead and solve for x, and then notice they want us to find how much angle A is. So first we have to solve for x, and then we have to plug it in here to find out how much angle A is. If you solved correctly and you divided this, you should get that x is 58. The only problem is they want us to actually find the measure of angle A. So you have to substitute it back in. So the final answer, measure of angle A, is 58 plus 2. So the final answer is 60 degrees. This question doesn't have a picture, and they want us to draw it first to be able to solve. So it says let O be between M and P. So see if you can draw the picture first. I will set it up with the information that they gave us here, and they said MP is 25, and then they want us to solve for x. See if you can do it. Hopefully this is the picture you drew, because it said O was between M and P. So O is between M and P. They told us MO was x plus 10, OP is 3x plus 3, and MP is 25. So the equation we need to solve is right here at the bottom. Go ahead and solve for x real quickly. Here is the rest of the work. Hopefully when you solved it, you got that x was equal to 3. This question says that angles A and B are complementary, and hopefully you know that means that they add to 90 degrees. If you want a picture, it could look something like this. It's two angles, A and B, and together they add to 90 degrees. Go ahead and solve for x and then find the measure of angle A. When you solve, you should get that x is equal to 36. The only thing is they want us to find angle A. So you need to take 36 and plug it in right there because it says angle A is x minus 7. So the final answer is measure of angle A is equal to 36, take away 7, which is 29. This is the final answer to the question. The next question says, in the diagram below, solve for x. So hopefully you marked this part, and you know that that all adds to 180, and that's called a linear pair, and they are supplementary. So solve by adding these two angles to equal 180, and see if you get one of these answers over here. So you're going to add 12 to both sides. You get 192, and then you have to divide that by 6. And when you do, you should get 32, which is choice D. This question says you have to use a compass and a straight edge to copy the angle. So if you look at this angle, it looks obtuse, and I can't really simulate it with the iPad very much, but I can describe and show you essentially what you need to do. So first you need to put the center of your compass here, and then you need to mark the angle kind of like that. And then what you're going to do is you're going to simulate this here, and then you mark the same angle like that. The next thing you need to do is actually measure the angle. So from this point to this point, you need to find out how big that is. So put the center of your compass here, put your mark here, and then you're going to simulate it over here, same thing. So you start here, put your center, and then you're going to mark how far it is. And the next thing that you'll do is then you'll just connect this to here. And if you were to use a protractor, this angle from here to here should be the same as this one. So it's something like this.